Here's a trig limits problem that I think bears sort of particular attention. Now, you might know if you were algebraically trying to do this that if you plug in 0, sine of 6 times 0, sine of 0 is 0, sine of 0 in the denominator, so we have an indeterminate form, 0 over 0. You might run through sort of, well, I don't know how to cancel, I can't rationalize, and pretty quickly get to really sort of my best hope is to get the limit as x goes to 0 of sine x over x. But you say, there isn't an x there. Well, here's the catch. I'm allowed to multiply by anything I want to. So I'd really like there to be a 6x in the denominator. Well, why not just multiply by 6x and 6x? Well, I'm going to add something else here, but let's just go ahead and say, okay, well, that makes life a little better for me. I have the sine of 6x over 6x, taking this term and this term. That's going to be nice. What's sort of left over? I guess I have 6x, and I have sine of 9x over here. Well, really, somehow what I'd like is I'd like 9x over 9x. So I guess I need an extra 9. Or maybe I can just give myself an extra 3. So if I add a 3 over 3, there was already a 6. So 6 times 3 gives me a 9 and a leftover 2. And somehow I have an extra 3 here that I don't want. So just double check that by multiplying by this clever one, I have that in the numerator, that in the denominator. Now here's the catch. This piece here behaves just like the limit that you know. For instance, let's imagine that we say y equals 6x and z equals 9x. Okay? Then this piece we could leave alone, right? We could say, well, the limit as x goes to 0 2/3 is in fact 2/3. This piece right here, that's the limit as sine of y over y, limit of sine of y over y as, well, what's y doing? As x is going to 0, can you see that y is going to 0? This piece is the limit of z over sine z as z goes to 0 for the same reason. Okay? Now, notice that sine x over x goes to 1, so its reciprocal also goes to 1. So now you can use that classic trig limit to say this is 1 times 2/3, or 2/3.